सपोर्ट वेक्टर मशीन, SVM, machine learning. तो history of support vector machine. SVM is related to a statistical learning theory. SVM was first introduced in 1992. ठीक है. SVM became most popular and SVM becomes popular because of its success in handwritten digit recognition. तो handwritten text recognition में support vector machine बहुत ऐसा famous है. It is famous because of that. 1.1% test error rate for SVM. This is the same as the error rate for a carefully constructed neural network, LET and LENet4. So LENet4 is a neural network and support vector machine has the same test error rate. ठीक है, तो टेस्टिंग केसेस में उसका एरर रेट इज सेम एज दैट LENet4, 1.1%. SVM is now regarded as an important example of kernel methods. It is an important example of kernel methods. One of the key area is machine learning. ठीक है. What is a support vector machine? The objective of the support vector machine algorithm is to find a hyperplane in an n-dimensional space. N is a number of features. ठीक है, तो we know n is the number of features. मतलब 2 feature होगा तो ऐसा x और y, 3-dimensional, 4-dimensional, more the features, more the dimensionality. So the objective of a support vector machine algorithm is to find a hyperplane in an n-dimensional space. Hyperplane is basically just a linear regression, linear line था, like dividing it. The hyperplane is like multidimensional. That distinctly classifies the data point. ठीक है, वही ना, तो it classifies the data point, like segregates and it tells you that this is this data and this is that data. ठीक है, तो support vector machine or SVM is one of the most popular supervised learning algorithms, understandably, because digit text recognition did insane work, which is used for classification as well as regression problems. ठीक है, it is used for classification is, as we know, it is grouping, and regression as we know is reducing. ठीक है. However, primarily it is used for classification problems in machine learning. Classification because again text recognition is classification problem. You like tell machine 1 कैसा दिखता है, 2 कैसा दिखता है, and all ahead. ठीक है. So here we have x2 and x1 and x2, x and y plane. Okay, we have circles and we got squares. Okay, and we have to divide them in 2 parts such that obviously we know that it has been classified, like 2 shapes have been distinguished and they have been classified as 2 different things. ठीक है. नाउ पहले एग्जाम्पल में एज यू कैन सी दैट दोज आर करेक्ट बट नॉट द मोस्ट ऑप्टिमम. ठीक है, मैं बोल रहा हूँ कि पेन लेते हैं, इवन दो पेन कलर, इवन दो ऑल ऑफ दिस माइट बी करेक्ट. ठीक है, बट दे आर नॉट optimum. ठीक है, but here this is the optimal plane, the optimum plane. It has a maximum length on both sides. ठीक है, within which all the shapes rest. बराबर. Let's see आगे क्या है. Take a different color. To separate the 2 classes of data points, there are many possible hyperplanes that could be chosen. ठीक है, to separate there could be many possible hyperplanes that could be chosen. और जैसे we saw at the last example, multiple hyperplanes थे, but optimum तो एक ही था ना. choose multiple कर सकते हो, but best वाला तो एक ही होगा, right? Our objective is to find a plane that has maximum margin. अगर एक लाइन बना रहे हो तो ऐसा प्लेन ढूंढो इसका मैक्सिमम मार्जिन हो, दैट इज मैक्सिमम डिस्टेंस बिटवीन डेटा पॉइंट्स ऑन बोथ ऑफ द क्लासेस. ठीक है, तो जितना बॉर्डर बना है ना, इमेजिन इट एज अ बॉर्डर बना, दोनों एक बॉर्डर के बीच में दोनों साइड पे जितना ज़्यादा गैप छोड़ोगे उतना बेटर होगा ना डिस्टिंग्विश करने के लिए, कि वो उस मार्जिन ही इतना है दैट यू कैन नॉट मेक एन एरर, क्योंकि इतना बड़ा गैप है दोनों के बीच में, ठीक है। ऐसा ओवरलैप कर दिया, मार्जिन कम हो गया तो द चांसेस ऑफ इट, द इवन द डेटा क्लासेस ओवरलैपिंग बिकम हायर, बट इतना गैप दे दिया तो चांस ही नहीं है एरर का। दैट इज वाई दे हैव अ इनसेन 1.1% एरर रेट एज आई सेड, ठीक है। थर्ड पॉइंट, मैक्सिमाइजिंग द मार्जिन डिस्टेंस प्रोवाइड सम रीइंफोर्समेंट सो दैट फ्यूचर डेटा पॉइंट्स कैन बी क्लासिफाइड विद मोर कॉन्फिडेंस। So wait, maximum the margin distance provide some reinforcement so that future data points can be classified with more confidence. वही ना, इतना इतना मार्जिन छोड़ोगे अच्छे खासा तो इट विल री एंश्योर, देख के ही पता चल जाएगा कि कौन सा किधर जाने वाला है। दैट इज easier for the future data points. Hyperplanes and support vector machines. Hyperplane is R2, like R square in a line, ठीक है। Hyperplane in an R3 is a plane. Obviously, टू डिमेंशनल में लाइन ही बनेगा ना, एंड थ्री डिमेंशनल में इट बिकम्स अ प्लेन। सो अंडरस्टैंड, वन डिमेंशनल में पॉइंट होगा, ठीक है। टू डिमेंशनल में वेर एवरीथिंग इज इन 2D, दिस बिकम्स इवन ऑल्सो दिस बिकम्स 2D, ऐसा 1D लाइन पॉइंट्स का, ठीक है। एंड हाइपर प्लेन जहाँ पे क्यूब है, मतलब पावर 3 है, थ्री डिमेंशनल है, वहाँ पे दिस बिकम्स अ 2D प्लेन। ओके, इतना समझा। Hyperplanes and support vector machines. Hyperplanes are basically division lines between the data. सर डेफिनेशन नहीं दिया क्या अब तक? नहीं दिया, never mind. टेक आ गया। Hyperplanes are decision boundaries that help classify the data points. बोला ना, Hyperplanes are decision boundaries that help classify the data points. क्या है वो? decision का boundary है that help classify the data points. Data points falling on either side of the hyperplane can be attributed to different classes. Well, obviously, if you're dividing something, what are you dividing? Classes, na? Also, the dimension of the hyperplane depends upon the number of features. ठीक है? Obviously, dimension of the hyperplane will depend ऊपर कितने class, नीचे कितना, मतलब ऊपर कितने objects, नीचे कितने objects, उसके according उसका dimension बनेगा ना? If the number of input feature is 2, then the hyperplane is just a line. Oh, here they mean about the dimensionality which we talked पहले. But if the number of input feature is 3, the hyperplane becomes a two-dimensional plane. बोला ना, 3D में, three-dimensional में it becomes a two-dimensional plane. Two-dimensional में it becomes a one-dimensional line. One-dimensional में it is, I don't think it is like single attribute, or what will you divide? So there's no plane existing. It becomes difficult to imagine when the number of features exceeds 3. Yeah, this is difficult for people who have not still been able to visualize more than 3 dimensions, but once you start grasping what more dimensionalities look like, what 4 dimensional looks like, a tesseract and all, then you'll be easily able to understand कि वहाँ पे भी 3 dimensional plane कैसा दिखेगा। स्मॉल मार्जिन, लार्ज मार्जिन, देख रहे हो? लार्ज मार्जिन, स्मॉल मार्जिन में देख रहा है, इट इज़ सो रिस्की कि अगर वो थोड़ा इधर आ गया ना तो वो सर्कल बन जाएगा, इवन दो इट माइट नॉट बी अ सर्कल। बट लार्ज मार्जिन छोड़ोगे, इंडिया पाक बॉर्डर है भाई, देखना, लिटरल, द मोर डिस्टेंस यू कीप द बेटर इट इज, सिंपल। Support vectors are data points that are closer to the hyperplane, ठीक है, and influence the position and orientation of the hyperplane. वो, so this is a new concept. Support vectors are data points that are closer to the hyperplane. जो line बना रहे ना अपन, support vectors are points which are closer to the line. Hence, they help in shaping the line. Pahad is what we divide na on a map. More pahads, more that pahad is what is gonna divide the line, give the shape to the line on a map. वैसे इधर support vectors are the data points that are closer to the hyperplane and influence the position and orientation of the hyperplane. Understood? Using these support vectors, we maximize the margin of the classifier. Using these support vectors, we maximize the margin of the classifier. ठीक है, सो उसको जितना दूर अपन पुश करते हैं एंड तक, बीच में लाइन बनाया अब, और जितना सपोर्ट वेक्टर के बाजू में जा सकता है ना उतना जाने का, ठीक है। डिलीटिंग द सपोर्ट वेक्टर्स विल चेंज द पोजीशन ऑफ द हाइपरप्लेन. देयर आर द पॉइंट्स, दीज आर द पॉइंट्स दैट हेल्प अस बिल्ड आवर एसवीएम. अभी अगर वो लाइन के बाजू में, यू इट डजेंट मैटर, अगर तू लाइन के एकदम दूसरे साइड का पॉइंट डिलीट कर दिया ना, वो तेरे लाइन का शेप चेंज नहीं करने वाला. but the points that are closer to the line, that is like closer to the other class, that is what is going to help shape the line ना, because वो काटने वाला है तुम दोनों क्लास को बीच में से. ठीक है, एक्सट्रीम एंड से फर्क नहीं पड़ रहा अपन को, बट सपोर्ट वेक्टर्स आर द डेटामर्स दैट आर क्लोजर टू द हाइपरप्लेन. दे हेल्प इन शेपिंग एंड ओरिएंटेशन, पोजिशनिंग एंड द ओरिएंटेशन ऑफ द लाइन और द हाइपरप्लेन. Deleting the support vectors will change the position of the hyperplane. दूर वाला करो फर्क नहीं पड़ रहा. These are the ones that help us build a support vector machine. Support vector machine बनाने के लिए क्या लगेगा? Support vectors और support hyperplane ना. Large margin intuition. In logistic regression, we take the output of the linear function and squash the value within the range 0 and 1, 0,1. ठीक है, क्या बोल रहे हैं ये लोग? In logistic regression, we take the output of linear function and squash the value within the range 0, 1 using the sigmoid function. बराबर. लॉजिस्टिक रिग्रेशन में अपन जब लीनियर फंक्शन यूज़ कर आउटपुट लेते लीनियर फंक्शन का, तो जो भी वैल्यू आया अपन 0 to 1 के रेंज में फिट करते ना उसको यूजिंग द सिग्मॉइड फंक्शन. सिग्मॉइड वो क्या था? वो साइन कर्व था एस शेप का. उसका जो भी आउटपुट आया 0 to 1 के रेंज में अपन उसको फिट करते हैं. सपोज लेट्स से 59 आया, किधर कर्व में फिट होगा? इट विल बी ऑब्वियसली अबाउट 0. It will obviously be above 0.5 ना. It will be 0.5 ना obviously because it's 0. It's 59, so divide कर लो. In SVM we take the output of linear function and the output is greater than 1. In SVM we take the output of the linear, same है. Logistic regression में भी output of linear function ले रहा है, SVM में भी output of linear function ले रहा है. And if the output is greater than 1, we identify it with one class, and if the output is -1, we identify it with another class. समझ रहे हो? इधर है ना वैल्यू कुछ भी आया दुनिया में, 5000 भी आया पहले वाले में लॉजिस्टिक रिग्रेशन में, तो भी अपन उसको 0 और 1 के बीच में फिट कर देगा क्योंकि सिग्मॉइड फंक्शन एग्जिस्ट करता है. ठीक है, बट इधर इन सपोर्ट वेक्टर मशीन वी टेक द आउटपुट ऑफ लीनियर फंक्शन एंड द आउटपुट इज ग्रेटर देन 1. मतलब बेसिकली 1 इज योर पार्टीशनिंग पॉइंट. आउटपुट इज ग्रेटर देन 1 तो वो एक क्लास को बिलोंग करता है, एंड अगर आउटपुट इज -1 तो वो दूसरे क्लास को बिलोंग करता है. ठीक है, वी आइडेंटिफाई दिस विथ अनदर क्लास. Since the threshold values are changed to 1 and -1 in SVM, we obtain the reinforcement range of values between 1, -1 and 1, which acts as the margin. ठीक है, because the threshold values have been changed to 1 and -1 in support vector machine, we obtain the reinforcement range of values from -1 to +1, which acts as the margin. Margin क्या है? 0 को margin बना दिया ना अभी अपन ने, and -1 and 1 are the margins. तो 0 and which भी जो gap है 1 and 1 on each and 1 unit का, that becomes the margin. Types of support vector machine. ठीक है, support vector machine can be of two types: लीनियर सपोर्ट वेक्टर मशीन एंड नॉन लीनियर सपोर्ट वेक्टर मशीन. सीधा कोई और है ही नहीं, दो टाइप एग्जिस्ट करता है. ऐसा तीसरा चौथा मल्टी लीनियर नॉन ऐसा है ही नहीं कुछ. लीनियर सपोर्ट वेक्टर मशीन. लीनियर सपोर्ट वेक्टर मशीन इज यूज फॉर लीनियरली सेपरेबल डेटा. ठीक है, व्हाट इज इट यूज फॉर? लीनियरली सेपरेबल डेटा, which means if the data set can be classified into two classes, two perfect classes, by using a single straight line, then such data is termed as linearly separable data, and classifier is used called as linear SVM. ठीक है, and this is pretty self explanatory. linear SVM क्या होगा? अगर तेरा डेटा दो क्लासेस एक लाइन से सेपरेट हो रहा है तो अपन लीनियर SVM क्लासिफायर यूज करेंगे. नाउ कमिंग टू नॉन लीनियर SVM. नॉन लीनियर SVM is used for non linearly separated data. ठीक है, which means if the data cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier uses a non-linear SVM classifier. तो अगर तू एक सीधी लाइन खींच के दो डेटा दो क्लासेस को डिफ्रेंशिएट नहीं कर पा रहा है, डिवाइड नहीं कर पा रहा है, तो कौन सा टाइप ऑफ SVM यूज़ करना पड़ेगा? नॉन लीनियर, बिकॉज तो एक लीनियर मतलब सीधा लाइन खींच के नहीं डिवाइड कर पा रहा था. ठीक है, हाउ डज SVM वर्क? लीनियर SVM पहला वाला दिखता है. The working of support vector machine algorithm can be understood by using an example. Suppose you have a data set that has two tags, green and blue. मतलब एक green class एक blue class है on the data set that is shown below, graph में plot किया. and the data set has two features, x1 and x2. We want a classifier that can classify the pair x1 x2 of coordinates in either green or blue. Consider the below image. Now सीधा भी divide कर सकते हो. So as it is 2D space, so by just using a straight line we can easily separate two classes. जो dimensionality है उससे एक dimensionality कम में तो अपना count कर सकता है division का of the space. But there can be multiple lines that can separate these classes. Obviously, तू ऊपर नीचे टेढ़ा मेढ़ा और कर, because the gap is only so much that you can fit many lines. But you have to obviously find the perfect fit जो green वाला किया है अच्छे से. It is dividing with a good margin, unlike the red one. तो देख बोला ना ग्रीन वाला परफेक्ट. तो हाउ डज सपोर्ट वेक्टर मशीन वर्क? Hence the support vector algorithm helps to find, how does it work, ठीक है पहले वो समझता है. The SVM algorithm helps to find the best line or decision boundary. ठीक है, algorithm machine SVM algorithm का काम क्या है? To find the best line or the decision line or the optimal hyperplane. The best boundary or region is called as hyperplane. ठीक है, वो लाइंस में से बेस्ट लाइन डिसीजन बाउंड्री सब में से सबसे बेस्ट वाले को है ना हाइपर प्लेन बोलते हैं. SVM algorithm finds the closest point of the lines from both the classes. ठीक है, तो दिख रहा है सपोर्ट वेक्टर लिखा दोनों साइड पे इधर. ठीक है, SVM algorithm finds the closest point of the lines from both the classes. These points are called support vectors. ठीक है, these distance between the vectors and the hyperplane is called margin. ये hyperplane है, optimal hyperplane. Distance between them is called margin, जो आपने 1 - 1 देखा था. And the goal of SVM is to maximize this margin. The hyperplane with maximum margin will be called optimal hyperplane. ठीक है, जो hyperplane में सबसे ज़्यादा margin होगा वो optimal hyperplane बन जाएगा. बरोबर. Next, how does SVM work? ये this is non-linear वाला. How does non-linear SVM work? ठीक है, if data is linearly arranged, then we can separate it by using a straight line. But for non-linear data we cannot draw a straight line. Consider the below example. below image देखो, ग्रीन सर्कल्स बीच में है, ब्लू ट्राइंगल साइड में, चारों तरफ है. तो अभी एक लाइन बना के डिवाइड नहीं कर सकता. ये लाइन कैन नॉट डिवाइड, दिस लाइन कैन नॉट डिवाइड. देयर इज नो वन सिंगल लाइन दैट कैन प्रॉपरली सेग्रीगेट दीज टू, एक्सेप्ट इफ यू एंड अप ड्राइंग अ सर्कल दैट स्पेसिफाइंग कि इसके बीच में जो आ रहा है वो सारे एक क्लास है, उसके अराउंड जो है वो सारे अलग है. So how do you do that? How do you like this? Support vector machine cannot draw a circle, I'm assuming. So how does it work? So to separate these data points, we need to add one more dimension. See, this is where third dimensionality comes in. So dimensionality डाल दो. For linear data, we have used two-dimensional x and y. So for non-linear data, we will add a third dimension z. It can be calculated as z equals to x square plus y square. X square plus y square is z. By adding the third dimension, the sample space will become below image. ठीक है, अभी अपन इमेजिन नहीं कर पा रहे, बट अगर इमेजिन करो अपन ने एक और डिमेंशनैलिटी ऐड कर दिया. ठीक है, एक और डिमेंशनैलिटी ऐड कर दिया. इसको थोड़ा उल्टा करता है. नेवर माइंड. ठीक है, तो अभी जो अपन को करंट डेटा दिख रहा था, ठीक है, उसमें अपने को ग्रीन सर्कल्स दिख रहे थे. अपने को ग्रीन सर्कल्स दिख रहा है. ठीक है, एंड वी कैन सी ब्लू ट्राइंगल्स. what we can see is blue triangles around. बराबर. but if you look properly in three dimensionality, imagine करो, imagine in 3 dimensions, can we not have this? Can we not have a hyperplane that fits it ऐसे, that divides these? हाइपरप्लेन ऐसे इमेजिन करो ऑन दिस. ठीक है, हो गया. दैट इज व्हाट द पॉइंट इज एट थर्ड डिमेंशनैलिटी. और फिर देखो रिजल्ट्स मस्त आते हैं. थर्ड डिमेंशनल कैसे ऐड होता है? z इक्वल्स टू एक्स स्क्वायर प्लस वाई स्क्वायर. By adding third dimension, the sample space will become the below image. So now SVM will divide the data sets into class in the following way. Consider the below image. देखा मस्त एक flat line divide. On z axis it is dividing. See? Z axis is the third dimension वाला. How does support vector machine work? Still we are on that. Since we are in 3D space, मैंने बोला ना circle in on a 2D space, circle would be the best way. Since we are in a 3D space, hence it is looking like a plane parallel to the x-axis. If we convert it into 2D space with z equals to 1, that will become as this. ठीक है, this is 3D से अपन ने वापस उसको 2D में कन्वर्ट किया तो it is looking like this because कट ही वैसे किया था. The blank slide. Support vector machine. The natural setting for support vector machine is classification. Natural setting मतलब natural setting for a support vector machine. हाँ ठीक है. Support vector machines are classifiers. So the natural thing for it to do is classify. So चाय वाले का काम चाय बनाना. It is a natural setting for him. Suppose that we have a set of points in two-dimensional. Suppose that we have a set of points in a two-dimensional feature space. 2D data space है. Graph है. X और Y axis वाला. With each of the points belonging to one of the two classes. ठीक है, दो टाइप की क्लास है, उस पर जितने भी पॉइंट्स एग्जिस्ट कर रहे हैं वो एक क्लास को तो बिलोंग करते ही है. एंड SVM finds what is known as a separating hyperplane. वो अपन ने पढ़ा. Support vector machine is finding the optimal separating hyperplane. A hyperplane that is a line in the two-dimensional case. In this case it is two-dimensional, which separates the two classes from points from one another. तो वही है जो अपन पढ़े. ठीक है, कुछ नया नहीं था. And the diagram H1, H2, H3 are all potential such hyperplanes. देखो this is ये मस्ती कर रहे हैं अपने साथ. अपन को क्लियरली दिख रहा है एक हॉलो सर्कल से एक सॉलिड सर्कल से. ठीक है, सारे हाइपरप्लेन है. हाइपरप्लेन तो कुछ भी लाइन खींच दे इसके ऊपर वो हाइपरप्लेन है. ठीक है, करेक्ट है क्या वो हाइपरप्लेन? नहीं ना. इज H1 सक्सेसफुली एबल टू डिवाइड टू क्लासेस? नहीं. इज H2 सक्सेसफुली एबल टू डिवाइड? यस. But is it the most optimum? Is it maintaining the highest margin possible? इधर मार्जिन देख दुनिया भर का है, बट इधर इट्स लाइक लिटरली ऑन इट मार्जिन नहीं है. बट H3 देखो, H3 has the maximum margin from both the data sets while still dividing it. The points in this diagram are clearly linearly separable. मतलब एक लाइन से clearly divide कर सकते हो अपन. There exist infinitely many lines which may partition them from one another perfectly. ठीक है, perfect partition तो बन जाएगा, but is optimum है या नहीं वो अपने को ढूंढना है. That is the whole मेहनत that we are doing ना. line तो कोई भी खींच लेगा. The H1 candidate hyperplane is clearly suboptimal because it is conflate the points belonging to other class. ये वो तो अपने देखा. H1 वाला दूसरे के अंदर जा रहा है तो नहीं चलेगा. Wrong division है. The H2 candidate hyperplane is a good solution. It linearly separates the points. In fact, it separates them so well that no point in the training set are even ever misclassified. Training set में देख, there's a difference. There's training set, there is testing set. ट्रेनिंग सेट पे ही अगर तू अपना टेस्ट रन करोगे तो वो तो वही डेटा है ना जो तूने ऑलरेडी दिया. उसमें कभी गलती करेगा ही नहीं वो, बिकॉज इट हैज फिटेड सो वेल. इतना बाजू में चिपक के बैठा है. बट हाउएवर doesn't it seem like H3 candidate hyperplane is the best solution? That is because H3 has the property that it maximizes the distance between itself and the nearest point in either class cluster. मतलब that is because the distance, that is the margin, has been maximized. तो अगर थोड़ा आगे पीछे भी आया ना पॉइंट तो भी वो क्लासीफाई हो जाएगा. समझ रहे हो? ट्रेनिंग डेटा में से नहीं, टेस्ट डेटा में कुछ नया भी आ गया ना तो भी वो क्लासीफाई हो जाएगा. In other words, H3 is the maximum margin hyperplane, and maximum margin hyperplane is what is the optimum hyperplane. Put another way, while H2 and H3 will have the same training error, 0%, we expect H3 to generalize better. That is, over the testing data also it will work, not only on the training data. देखा आपने SVM has 1.1% testing error, testing set पे error. Training पे तो it is very difficult. If your algorithm is only wrong ना, तो जाके training data में error आता है. If the model is so poorly trained, because training data is literally what you train the algorithm with, your model with. उसमें ही error आएगा तो it is थोड़ा ऐसा अजीब. H2 and H3 will have the same training error, 0%. Except H3 to generalize better to. We expect H3 to generalize better to new unseen data, as new points are less likely to accidentally strain to another class partition of the space. Testing data is different than the training data. Take a more unseen it is to the model. It is newer to the model. So H3 works better because it has higher margins. So it is able to account for the new data as well, not only the training data. Sometimes the points are not linearly separable. For example, suppose that class are distributed according to the diagram on the left here. Ocean लग रहा है मेरे को तो वो पानी में लोग हैं, बाहर बीच पे भी लोग हैं. ठीक है. Now you see, it's not a straight line, it's a curve. More like many curves. It has curves in it. ठीक है. Now how do we fix this? In this case, there is no line. We can draw that will separate the class. In this case, there is no line that we can draw that can separate the classes. However, we can do one thing in this case is transform the space somehow. अपन इसको ऐसा expand कर सकते हैं थोड़ा. पता है अपन image को perspective expand करते हैं वैसा. So that we can bring these points, we can push this whole thing वहाँ पर थोड़ा. ठीक है, देख रहे हो ये सारे points which are over here have been pushed here. How do you do that? The function responsible for transforming the space so that the resulting points are separable is known as the kernel. So what is kernel? Kernel is the function responsible for transforming the space so that the resulting points are separable. The simplest possible support vector machine, the linear SVM, has linear kernel. That is, वो linearly divide करता है. It divides the feature space into a set of lines, hyperplanes, and higher dimensional spaces. Other possible kernel includes degree and polynomial kernel. Degree and polynomial kernels, which separate the space using degree and function curves, and other more exotic forms. Damn, bro. Other possible kernels include degree and polynomial kernels. Degree and polynomial kernels, which separate the space using degree and functions. Degree and functional curves, and other more exotic forms. There are types of kernels. Linear kernel. The feature space types of kernel. Linear kernel. The feature space corresponding with a linear kernel is the space. In other words, a linear kernel is a direct translation of Euclidean distance. Oh my god, that is insane. That is insane. The feature space corresponding with a linear kernel is the space. The feature space corresponding with a linear kernel is the space. In other words, a linear kernel is a direct translation of Euclidean distances, and there's no shadowy n-dimensional space involved at all. Linear kernel support vector machines have good performance only on a very simple problem, like the toy iris dataset. The more indecipherable the boundaries between class clusters become, the worse the performance of the algorithm. The more indecipherable the boundaries between class clusters become, the worse the performance of the algorithm. Basically, जो boundary है classes के बीच में, तो जितना कम उसको distinguish कर पा रहा है ना, the worse the cluster becomes, the worse the performance of the algorithm. मैं क्या बोलना चाहता हूँ, ये देखो, ये देख रहे हो कैसे browns have started to overlap in the yellows. ठीक है, even though this is the maximum brown portion. ठीक है, the more indecipherable the boundaries between class clusters become, the more indecipherable the boundaries between class clusters become. Indecipherable मतलब you cannot divide it. ठीक है, इधर division possible. Blue is still being able to divide, but on what give that this blue is almost on the boundary. What does that do? It makes the algorithm ka performance kharab. Now how do you solve this? Because this is clearly it is possible to divide it linearly, but बहुत खराब चलेगा algorithm. मतलब the टेस्टिंग एरर में इतना टेस्टिंग एरर आएगा ना, तो दैट इज नॉट गुड. सो पॉलिनॉमियल कर्नल इज व्हाट वी यूज. सो व्हाट इज अ पॉलिनॉमियल कर्नल? The feature space corresponding with the polynomial kernel is the same as the polynomial regression. Each feature x is copied over to x2, x3, and so on up to degree, so only to 3 in this case. And then separating hyperplanes are drawn in that feature space. Drawing them in 2 dimensions as here demonstrate the polynomial nature to degree. इधर देख रहे हो, अभी ये था तो सही अपने पास. What did we do? Made curves. Even though, see the first thing, ये blue is free now. So blues are clearly separated. Even though these yellows are thoda overlapping with browns, but majority of the yellows are here in the red space, and majority of the browns possible are in the brown space. Unlike in linear kernel. तो polynomial kernel क्या करता है? पॉलिनॉमियल कर्नल तो एन डिमेंशनल, क्या था, एन डिमेंशनल फंक्शन यूज़ करता है. डिग्री एन पॉलिनॉमियल कर्नल यूज़ करता है, एंड एन डिमेंशनल फंक्शनल कर्व्स यूज़ करता है, डिग्री एन फंक्शनल कर्व्स. ठीक है. ड्राइंग देम इन 2 dimensions as here demonstrates their polynomial nature to degree. RBF, radial basis function kernel. रेडियल बेसिस फंक्शन. रेडियल सुनते ही तुम्हारे दिमाग में एक पॉइंट और सर्कल बनना चाहिए, एक डॉट और एक सर्कल. RBF is the most, radial basis function is the most popular support vector machine kernel choice, and the default one is sklearn. Oh my god, that is sklearn. RBF is a type of function that is used to approximate other functions. The math is complex, but basically translates into the kernel that can create the most complex boundaries of ones available to sklearn. Now what you see right now, unlike the previous one जहाँ पे नॉन रेड एरियाज में भी डॉट्स नहीं थे एंड ब्लू एरियाज में भी डॉट्स नहीं है, इधर इट क्रिएट्स द बेस्ट पॉसिबल चॉइस. ठीक है, यूजिंग कॉम्प्लेक्स मैथ, most complex boundaries. It looks only complex. You wouldn't on first guess, on visual first guess, तू ये नहीं बनाता. You would have created something like this. ठीक है, but this is complex. It creates it by using complex math. Note that computing an RBF kernel is very expensive. Expensive मतलब पैसा लगता है on what? The computing power. ठीक है, computationally it is very expensive. And quickly becomes computationally intractable as the number of samples exceeds the low tens of thousands. ठीक है, as soon as it becomes intractable. Intractable मतलब to track नहीं कर सकता उसको, as the number of sample exceeds the low tens of thousands. एक बार 10,000 के ऊपर चला गया ना, तो it becomes very difficult, and it very quickly becomes very difficult to interact with the data and with the samples. That is radial basis function. sklearn है, उसमें complex math यूज होता है and very expensive to computationally interact, exceeds low tens of thousands, मतलब 10,000 के ऊपर चला गया तो. Sigmoid in general is a term for S-shaped curve like. ठीक है, sigmoid is basically a term for S-shaped curve like. In the case of this parameter is probably referring to the logistic function which plays a central role in logistic regression. Sigmoid in general is a term for S-shaped curve like. In the case of this parameter, it is probably referring to the logistic function which plays a central role in logistic regression. This classifier actually collapses on the iris dataset, but empirically it is known to have performance comparable to RBF for a variety of problems. मतलब क्या? Sigmoid है, ठीक है, sigmoid kernel है, kernel लिखो ना. Sigmoid in general is a term for S-shaped curve like. ठीक है, अभी इसका S-shaped curve है ना, I guess, I'm not sure, it looks something like this. It grows, peaks here, dips here, and then grows in reverse here. This is what the S would look like, because तो ही ये yellow separate हो गया ना brown से. In this case of this parameter is probably referring to the logistic function, which plays a central role in logistic regression. This classifier actually collapses on the iris dataset, but empirically it is known to have performance comparable to RBF for a variety of problems. The classifier actually collapses on the iris dataset, but empirically it is known to have performance comparable to RBF for a variety of problems. The kernel trick. We maximize the margin, the distance separating the closest pair of data points belonging to the opposite class. These points are called support vectors because they are the data observers. Support ये अपन ने कर लिया है. The kernel trick. Hyperplane. A hyperplane in p dimensions is the p1 dimensional flat subspace that lies inside the larger p dimensional space. Flats in two dimensions, the hyperplane is just a line. And here, so there is p1 hyperplane in p dimensions is a p1 dimensional flat subspace that lies inside the larger p dimensional subspace. Never mind. Hyperplane की equations है, obviously. Non-linear transformation है. How much of this we got? Oh, not that much. We're almost at the end. Non-linear transformations. If the data is not linearly separable in the original or input space, then we apply transformations to the data, which map the data from the original space into a higher dimensional feature space. जो बोल रहा है, if the data is not linearly separable, अपन ने पहले देखा non linearly separable data को in original or input space. Then we apply transformation to the data, which map the data from the original space into higher dimensional feature space. वो देखा, SVM दो टाइप के थे, linear and multi dimensional वाले. ठीक है, मल्टी डिमेंशनल बोलते थे ना उसको. देख लेते एक बार वापस जाके ना पीछे. टू टाइप्स ऑफ सपोर्ट फंक्शन. अच्छा, लीनियर एंड नॉन लीनियर था. तो एज वी सॉ, नॉन लीनियर है तो अपन क्या करते हैं, हाई डिमेंशनल इंट्रोड्यूस करते हैं, z equals to x square plus y square. The goal is that after the transformation to the higher dimensional space, the classes are now linearly separable in the higher dimensional feature space. We can then fit a decision boundary to separate these classes and make the prediction. The decision boundary will be a hyperplane in this higher dimensional space, obviously. Non-linear transformations. In one dimension, this data is not linearly separable. But after applying the transformation, theta x equals to x square, theta भी नहीं इसको बोलते क्या है, and adding the second dimension to our feature space, the class becomes linearly separable. One dimension को अपने टू dimension में demonstrate किया तो ये बन रहा है ना एक लाइन. ठीक है, ये भी एग्जाम्पल. इधर x स्क्वायर किया, इधर x mod 2 किया, कुछ तो भी applying. Any some sort of transformation is being applied to divide them. Now non-linear transformations, original data is not linearly separable in two dimensions. ये तो अपन ने देखा है. They will introduce a third dimension, x3, that is z, and then they'll introduce a hyperplane, which when converted back to 2D will be a circle around this. Non-linear transformations. Apply the following transformation. So I guess, अच्छा, apply the following transformation. Equation second degree polynomial matrix. x1 x2 है, something that they are doing. Root 2 x1 x2 x1 whole square x2 whole square matrix बन गया. I don't know. Non-linear transformations. Our data becomes linearly separable by a 2D plane in 3 dimensions. Our data becomes linearly separable by a 2D plane in 3 dimensions. वो तो पता है. और 2 dimensional में it is separated by 1D line. Kernel trick. वापस kernel trick. When there are more and more dimensions, computations within that space become more and more expensive. This is when the kernel trick comes in. It allows us to operate in original feature space without computing the coordinates of data in higher dimensions. Whoa, that is insane. But man, computer science is like, this is when the kernel trick comes in. It allows us to operate in original feature space. Original feature space क्या था? वो तो two dimensionally था. Iterations and the values. There are just values. ठीक है, never mind. This is when the kernel trick comes in. It allows us to operate in original feature space without computing the coordinates of the data in higher dimensional space. मतलब तो एक को conversion की ज़रूरत ही नहीं है. Pass दिया उसका मतलब ये नहीं, you will have to convert it into a 5 dimensional data space. The kernel trick is that only. It allows us to compute in the same dimensional space. Oh, I thought they'll give an example, but yes. That is support vector machine done. Let's go through it ऊपर से फटफट. Support vector machine history बताया 1.1% test rate used for handwritten digit recognition. What is support vector machine? Support vector machine algorithm is basically to find a hyperplane in n-dimensional space, used for classification as well as regression problems, but mainly for classification. ठीक है. Hyperplane क्या है? Hyperplanes are decision boundaries that help classify the data points. Support vectors क्या है? Support vectors are data points that are closer to hyperplane and influence the position and orientation of the hyperplane. Large margin intuition क्या होता है? That the greater the margin distance between the two, it is better. 1 और -1. Logistic में 0 और 1 के बीच में split होता है. Two types होते हैं, linear SVM and non-linear. Linear is basically where the SVM classifier is linear SVM classifier and the data is linearly separable. Non-linear में there is need of higher dimensionality to be introduced because the data cannot be separated linearly. Z equals to x square plus y square. It's the basic. Oh, this is a blank slide. Let's get rid of that. Support vector machine. The natural setting for support vector machines classification. Separating hyperplanes. Maybe we did. This is the same. Then this is polynomial. Degree and polynomial kernels आ जाते हैं, where they are able to change the position and modify the space. Degree and functional curves. Degree and polynomial kernels, degree and functional curves. इसको highlight कर दो. फिर क्या है? लीनियर कर्नल तो पढ़ा. लीनियर कर्नल के बाद क्या आएगा अपने पास? पॉलिनॉमियल कर्नल. देन देयर इज रेडियल बेसिस फंक्शन. ठीक है, एस के लोन होता है उसके अंदर, वेरी एक्सपेंसिव, कंप्यूटेशनली इंटरैक्टेबल नहीं होता आफ्टर 10,000 सैम्पल्स. देयर इज सिग्मॉइड एस शेप लाइक कर्व. द कर्नल ट्रिक हाइपरप्लेन. कर्नल ट्रिक क्या था इधर? सेम ईयर डिस्टेंस वाला. हाइपरप्लेन ये तो अपन ने पढ़ लिया. हाइपरप्लेन का इक्वेशन है, नॉन लीनियर ट्रांसफॉर्मेशंस है. दिस इज मोर ऑफ द सेम थिंग. कर्नल ट्रिक. नाउ दिस कर्नल ट्रिक इज इंटरेस्टिंग, लास्ट वाला. दैट इज it allows us to operate. This is when there is more dimension, more expensive. So there's a kernel trick that allows us to use the original feature space without computing the coordinates of the data in a higher dimensional space and still create a hyperplane. That is, we're done with support vector machines. Let's go.